Okay, enough's enough. This is something that ought to scare the whole world when it happened, especially because instead of that giant bomb that was dropped on Nagasaki and Hiroshima, they now can put atomic bombs in some very small warheads. There's an example. Each one of those is an atomic bomb. Pardon? Each one of those sits on the tip of a missile, and it's an atomic bomb. That's how miniaturization took the atomic bomb from something as probably 4 times as big as that table to a tiny nose cone on the tip of a Polaris missile in a submarine.
So that could destroy this.
Pardon? Oh, sure.
How big is it?
Well, you can see that person walking over there, so I'll give you some idea. It doesn't make any difference how big it is. The fact is that they are much smaller than the giant little boy and, what was it, fat something and... Yeah, you guys know better than I do. Okay, that's good. Am I glad? All right, ICBMs and SLBMs with solid fuel. And solid fuel, it took them a long time to develop really good, consistent solid fuel that would burn inside a rocket, and it would burn inside consistently. That is, parts of it wouldn't explode, parts of it wouldn't burn at a certain rate. The solid fuel all had to burn at a specific rate. Now, you know what ICBM stands for, right? Intercontinental Ballistic Missile. And what do you think the SLBM stands for? Submarine-launched ballistic missile. That would be the Polaris that were installed in all the nuclear subs. That's what a solid fuel rocket looks like. Remember that if it was a hydrogen-fueled rocket, there would be no visible or a very slight visible exhaust, right? Because hydrogen burns clear, very faint blue color, but it burns essentially clear. So as soon as you see something like that with a long tail of exhaust or burn, it means that it's a solid fuel rocket. And we also developed vertical takeoff and land fighter jets. It's interesting because they really have not developed to the point where they're as highly produced as some of the other fighters that we have, the ones that do not land and take off vertically. And I think it probably is partly because all of our training, all of our pilots, all the aircraft carriers, all the airports around the world where our military jets land are all geared for the normal takeoff and landing. So the pilot training is a real big issue. It probably takes a lot longer to learn how to fly a vertical takeoff, land and takeoff aircraft than it would be a regular conventional jet. So here's a typical vertical land and takeoff jet that is simply firing the jet down. That's what's keeping it in the air. And the problem is balance, where the nozzles that control the jet down below have to be perfectly aligned. If they even slightly move one way or the other, the jet will fall off either side, front, back, or left or right side. So in this particular case, I mean, it's a good weapon and it's a good fighter, but whether the advantages are truly there or not for long-term use and high production levels is another question. As you can see, that jet engine in the back, the nozzle turned all the way 90 degrees from pointing directly back to pointing straight down. There's another nozzle in the center, out in here somewhere, that sucks air up in here. This is a door that opens up and sucks air down through. And so you've got two sets of airs pushing on the runway to lift that off. It's really more complicated, I think. I mean, I think that they thought it was probably a good idea, but in actual practice, it becomes more complicated than they thought. There you get some idea of what the two jets look like, the two exhaust areas. You know, it shows blue for the front one, and I'm not sure. Maybe that is only air blowing rather than a jet exhaust, because it shows the jet exhaust in red. And that's true because it's coming from the jet engine. So I suspect that this is simply a fan that is controlled by the jet engine. And so this, I believe, this appears to be just regular air being blown down. And stealth fighters. So let's take a look at one of those, and we'll question, why is it stealth? Well, because if you take an electron or a photon or any kind of an atomic particle and you fire it at that aircraft, almost no matter where it hits on that aircraft, whether it hits here, it's going to bounce off into space. What is this? Okay, as I was saying, the reason it's designed that way is so it deflects these atomic particles that are supposed to bounce off and come back to the radar site. That's one of the reasons for the odd angles on the aircraft itself. Also, it's painted with some type of absorbing paint that absorbs certain kinds of particles that are expected to hit it and go back to the radar site. Here's another example. Again, it's one of those examples where very low profile and odd shapes make for very stealthy flying. Apparently in Iraq, when we put the F-117 in Iraq, which is a stealth bomber, they never ever detected that bomber on their radar. It came and went completely free as it wanted to. It could make as many runs on Baghdad as it wanted to, and it was never discovered by the radar. Here's our F-22, F-35 series. Again, it's supposed to be radar absorbing, and you can see there's a different layer of something on the leading edges of all the surfaces. That's this radar absorbing material that is very, very effective. So for the first time, there were females in combat aircraft, although for a long time they would not let them fly in combat. But they taught them to fly F-18s and the other aircraft in our arsenal and got them ready for combat. But I believe it was only about 20 years later when they finally said, okay, we're going to allow women to actually fly in combat. Unmanned aerial vehicles. We know about those because we get reports from the government every now and then that one or another of the heads of these terrorist organizations are obliterated because of a UAV. And the Reaper is one of the most deadly because it has a lot of armament. It could stay aloft for a long time. It has incredible cameras and video cameras, still cameras and video cameras. It's one of those things where everybody in the Middle East fear this, partly because they can't hear it. It's high enough and the engine is quiet enough so that even if they could see it, they wouldn't be able to hear it and they wouldn't know for sure what it was. And as you know, we've been blowing people up right and left over the last couple of years if we know that they're terrorists. Tilt rotor is an interesting concept. It's probably the single aircraft that gave the Air Force and the Marines the toughest time of trying to get it into production and make it successful. It's an awkward-looking unit because those engines tilt forward in order for it to fly horizontally. And look how awkward it is in terms of the size of the propellers. I'm not even sure how that can land without the propellers, being so close to the ground. Not the way they are now, but when they tilt them, they're blasting dirt and dust over the entire helicopter itself. So one blade is blasting it as much as the other blade. So I don't understand how they can do it. Anyway, we're going to stop here, and we'll pick up the next segment tomorrow, and you guys can go ahead and take a 12-minute break. I know, isn't that something? Pardon? Yeah.